Okay, this is 2010, number 1. There's no snow on Janet's driveway when snow begins to fall at midnight. From midnight until 9 a.m., snow accumulates on the driveway at a rate modeled by this function, cubic feet per hour, where t is measured in hours since midnight. So 0 would be midnight, and 6 a.m. would be 6, and so on. So Janet starts removing snow at 6 a.m., and the rate g of t in cubic feet per hour at which Janet removes snow from the driveway at time t after midnight is modeled by this function. So here, from 0 to 6, from midnight until 6 a.m., she's still sleeping, right? So she's not removing snow. And then from 6 to 7, during the first hour, she removes it at 125 cubic feet per hour. And then I guess she gets a little tired. For the next 2 hours, she removes it at that rate. All right, first question. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? Well, here's the rate. So the amount of snow is the integral of the rate, right? So part A, we want to find the integral from 0 to 6 of the rate, which is 7t e to the cosine t dt. So let's see, let me just make sure I am in radian mode, because I got a cosine here. So math 9, I want to find the integral of function 7x e to the cosine x, comma x, comma 0, comma 6. So it looks like 142.275 cubic feet have accumulated in the driveway. Okay. Part B. Find the rate of change of the volume of snow on the driveway at 8 a.m. Well, there's two things happening at 8 a.m. The snow is the rate that snow is accumulating we can get just by plugging 8 into this. And the rate that she's removing it at 8 a.m. is this. So we have this accumulation minus her removing it at this rate. So we could say that the rate of accumulation is equal to the rate that it's building up at 8 minus the rate that it's being removed. Right? So let's do that. Plugging 8 into that function, I have 7 times 8, which is 56 e to the cosine of 8 minus 108. That gives me, now what does it mean that it's negative? If the rate of accumulation of snow is negative, that means snow is actually being removed. In other words, she's shoveling it off faster than it's falling, which I suppose is a good thing if you're Janet. So that's negative 59.583 cubic feet per hour. Right, it's a rate. Part C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain from 0 to 9. So they want us to make a piecewise function h that represents the total amount of snow that she has removed from the driveway. All right, well look, from 0 to 6, she's not removing it at all. So she will not have removed any snow. So from 0 to 6, she hasn't removed any. Now, this is the rate that she's removing it at, right? So if we want to know the total amount of snow that she's removed, then it's this. If she's removing it at a constant rate, then the amount that she's removed is 125 times how much time she's been doing that for, right? So 125 times how much time she's been doing it since 6 a.m., right? Because this is only from 6 to 7. So your first thought might be to do 125t here, but that would put a 6, like, because this is going to be the 6 to 7 piece, right? And it's really only from 6 to 7. This is when she first starts to do it. So instead of multiplying by t, we really need to multiply by t minus 6, right? So that at time 6, that's when this starts ticking up. And by time 7, 7 minus 6 will be 1. She will have removed 125 cubic feet of snow. Of course, that makes sense because that's her rate per hour. Now, how much has she removed in the 7 to 9 time period? Well, by the time it gets to 7, she's been removing it for 1 hour at this rate. So she's already removed this much. This is like a plus C here, right? Plus, now she's removing it at 108 cubic feet per hour, but this time doesn't start ticking till 7. So now we have t minus 7 here. There's more than one way to do that, but that's the way that really makes sense to me. You could think about it like just purely as antiderivatives and finding like the plus c's, but it really amounts to thinking about it in a very similar way to this. So that's a little bit tricky, but that's what the answer should look like. And then finally in part D, how many cubic feet of snow are on the driveway at 9 a.m.? Well, at 9 a.m., the total amount is the amount of snow that's fallen. So in other words, the total amount of snow from time 0 to time 9 under the f of t, right? That's the rate that snow is falling, minus the total amount that she has removed. Now, how much did she remove? Well, from time 6, actually you could plug 9 into your function. We have it right here, right? But just kind of thinking through this again, for this hour, she removed it at 125 cubic feet per hour for 1 hour, and then she removed it at 108 cubic feet per hour for 2 hours. But notice if you plug 9 into this, that's exactly what you get. You end up subtracting off that same thing. So let's do that. I think if I go back a couple entries ago, yep, I can just change that to a 9. Right, there's my fn into my function from 0 to 9. Sorry, old TI-83 has to think very hard. 367.33335, and then I'm going to subtract 125, and then I'm going to subtract 108 times 2. And that gives me 26.335 cubic feet of snow. All right, good job, Janet. That's not very much snow.